The first problem requires that we add the numbers 3,596, 88, and 379. We are therefore going to add the numbers together. Write down the first number. The first number is 3,596. Next, we are going to write down 88. We are going to place the ones digit under the ones digit. But before we do so, we are going to include the place values. Now that we have the place values, it is plain to see where the ones digit is. So we are going to put 8 under the ones digit. Then we are going to place the tens digit of 88 under the tens digit of the number that we have already written down. Next, we are going to write 379, and we are going to progress in a similar fashion by placing the ones digit under the ones digit. Then we place the tens digit under the tens digit. Place the hundreds digit under the hundreds digit. Now let us add the numbers. Now what do we do, Jerry? Do we begin by adding the digits beginning at the digit that is to the left? Do we do that? We are going to begin by adding the numbers in the ones column. So in the ones column, we have 6, 8, and 9. 6 plus 8 plus 9, that is equal to 23. So what do we do? Write the 3 in the ones column and carry the 2 to the tens column. The 3 will therefore be in the ones column, and the 2 will be carried to the tens column. Next, add the numbers in the tens column. What do we know? The 2 that was carried from the ones column is also included. So we have this time 2 plus 9 plus 8 plus 7. And those are the numbers that we have there: 2, 9, 8, 7. What do we do? We will add the numbers 2, 9, 8, and 7. The result is 26. What do we do? The 6 is written down in the tens column, and the 2 is carried to the hundreds column. Add the numbers in the hundreds column. What are the numbers? 2, 5, and 3. 2 plus 5 plus 3 is equal to 10. Write down the 0 and carry 1 to the thousand column. Finally, add the numbers in the thousands column. Three plus 1. That is what we have right here. The numbers in the thousand column are 1 and 3. So we may say 1 plus 3, or we may say 3 plus 1, and that is equal to 4. And that is all there is to it. The answer is therefore 4063. And this is represented by option D. Okay. Yes. All right. So Jerry Lewis is telling me that we did not need to perform the entire addition in order to determine the answer. So we are going to make use of Jerry Lewis's approach on the next slide. So Jerry Lewis is going to tell us exactly what to do this time. So under examination conditions, students might want to use a time-saving strategy. And Jerry Lewis is letting me know about a strategy that may be used in order to save time. Right? So I'm taking a suggestion from him. I hope that it works very well, in order that the students may save some time in solving the same problem or a similar problem. Add the numbers in the ones column first. But Jerry, this is the same thing that we have done before. Are you sure that we'll be able to save some time? Okay, yes, so continue and let's see. Okay, we'll do just that. 6 plus 8 plus 9 is equal to 23. So write the 3 in the ones column and carry the 2 to the tens column. Okay. Next, add the numbers in the tens column. The same thing we are doing over and over again. So I need to see how quickly we can get this one done. So we are going to add the numbers in the tens column. We have 26. Write down the 6 and carry the 2 to the hundreds column. Okay, Jerry. Oh, there it is. The correct choice may be determined at this stage, since only one choice ends with 63. That's very nice, Jerry. Here we have it. There's only one choice that ends with 63, so it is not necessary for us to add all of the digits. That's very good, Jerry. The answer is therefore 4063, and our choice is D. The answer could have been determined after adding the numbers in the first column, if only one of the choices ended with a 3. All Jerry is saying is that we need to progress until we are sure, by examining the digits that we have at the end here, that all Jerry is saying that we need to do is to progress as far as it is necessary to identify the correct answer based on what the end digits are. So when we added the numbers in the ones column, we ended up with a number that ends with a 3. Now, right here we have two numbers ending with a 3. So the possible answers could be this one and this one. So all we need to do now is to add the numbers in the tens column and see what the digit is. The digit being a 6 means that this one is our correct answer. So if we are going to be saving time in the examination, as soon as we are sure that the digits that we have uniquely identifies the correct choice, we need not continue beyond that point. Which number is 4 thousandths? Students should take note of the ending of the number. The number ends with THS instead of B, so it is not thousand, or thousands. It's thousandths. Okay, so the TH indicates a decimal fraction. We may take a tip from the fact that 1,000 has 3 zeros to determine that the correct answer should have 3 decimal places. So because 1,000 has 3 zeros, we can use that as a rule, or we can take that as a clue that we need to have 3 decimal places. If so, the correct answer is option C. It has 3 decimal places. We may also take a look at the place values. So we may look at the place values that indicate whole numbers and decimal fraction. So there we have a very large number, and we accompany that very large number with somewhat of a tag that indicates the place value of each digit. The number is 4,000. That is the one that we are trying to write down, or that is the one that we are trying to identify. 4 thousandths. The digit is required to be in the thousandths place. So if we are going to have the 4 in the thousandth place, we have to have the number written like this: decimal point for decimal point, decimal place for decimal place. And this verifies that our correct option is C. Question number 3 requires that we multiply 608 by 9. Let us arrange our numbers in preparation for multiplication. So help us with this one now, Jerry. What do? We say 9 multiplied by 8 is 72. Write down 2 and carry 7 to the tens column. Nine multiplied by 0 is equal to 0. The 7 that was carried is now added, and the result is 7. Next, we say 9 multiplied by 6 is 54. With no number carried and no thousands column, we just write down 54. The 4 is placed under the hundreds digit, which is the 6. So the 4 in 54 is going to be placed vertically below this 6. And the 5 is going to be placed where the thousandth column would have been. Okay. The correct answer is option B. Now we are at question number 4. What is the missing number in this set? So we have a set 1, 2, 4. A number is missing, and this set ends with 11. Let us write down the first 3 numbers in the sequence. A pattern may be observed if we know the difference between consecutive terms. So the difference, of course, difference in mathematics means what, Jerry? Okay, right. The difference between 2 numbers is the result of subtracting one from the other. So we are going to say 2 minus 1, and what is that? 1. Also, we need to determine the difference between the 2 and the 4. And we say 4 minus 2, and that is equal to 2. The differences seem to have the pattern of the counting numbers 1, 2, 3, 4. So I have 1, 2. Maybe the next number is a 3, then 4, then 5. But of course, we cannot be absolutely sure. And we'll demonstrate at the end how we may be exactly sure. But we cannot be sure at this stage that we are correct in saying that the pattern is 1, 2, 3, 4, etc. But let us say then, at this stage, that is what the pattern is. Let us use that pattern and see if we are correct. So let us assume that the difference between 4 and the missing number in the sequence is 3. So we are going to say the difference between 1 and 2 is 1. Then between 2 and 4 is 2. So we have 1, 2. So the difference between 4 and the missing number, we are going to say the difference between those two numbers is 3. So if the difference between the two numbers is 3, what do we know? The other number will be 4 plus 3 is equal to 7. Okay. Therefore, we are going to say then the correct answer seems to be 7. And this is represented by option C. And we are indicating it right there. If it is not so, then we'll do the calculation all over again. We use the word seems. That is, we are saying that the correct answer seems to be 7. We are using the word seems because we need to ensure that the pattern will generate the last number in the sequence. Therefore, we have a number right here which is 11. If we continue the pattern 1, 2, 3, will the next number in the sequence be 11? If so, then the pattern that we have developed is actually correct, and we may leave our answer as 7, which is represented by option C. So there we have 11. What is the difference between 7 and 11? The difference is 4. Okay, good. Because by including the last term in the sequence, the pattern that we have here is maintained, then we are sure that 7 is our correct answer. We see that the pattern is maintained, confirming that our correct answer is 7. However, students need to understand that the obvious pattern is not necessarily correct. So, we need to use the final number in the sequence to verify our answer. So if we are solving a problem like this and we see or we think that we see a pattern very early, we do not conclude that that pattern is correct. We continue the sequence up to the last number that is given in the set, and if the pattern is the same throughout the entire sequence or set of numbers, then we are sure that our answer is correct, as in this particular case. How many quarters are in 12? If a question asked, how many tens are in 100, what would you do? We would divide 100 by 10. We will therefore interpret the problem to mean that we will divide 12 by a quarter. The inclusion of a quarter means that we are manipulating fractions. We therefore write 12 as a fraction. So, because we are working with fractions, of course we have a quarter. Then if we convert everything to fractions, then everything will just be fine. Now, Jerry, how do we write 12 as a fraction? That is a long answer, Jerry, but it is correct. 12 divided by 1 is equal to 12. Therefore, 12 may be written as a fraction as 12 over 1. And this is your favorite mathematical operation that we are going to be doing now, Jerry. So you should be very enthusiastic about it. When we are dividing fractions, the divisor is inverted and the sign change from division to multiplication. So we are going to do a fraction inversion right now, which is, as a matter of fact, we have a very big word for that. We are going to find the reciprocal of the fraction, or we are going to reciprocate the fraction. So let us do that. Good. Multiplying the numerator 12 by 4, we get 48. And of course, if we multiply the denominators, we will get 1. Therefore, we have 48 to be divided by 1. And any number divided by 1 is equal to 1. Is that right, Jerry? Okay. Any number that is divided by 1 is equal to that same number. So 48 divided by 1, as Jerry said at the beginning of this problem, is going to be equal to 48. The correct answer is option A. In this one, we are required to multiply 4,000. So in this one, we are required to multiply 4,601 by 4. Let us arrange our numbers in preparation for multiplication. Okay, Jerry. We'll see if we can use your strategy and arrive at the answer in a very short space. Right, because Jerry is letting us know that we do not have to multiply the entire thing. We can use a time-saving strategy and arrive at our answer. So let us see if Jerry is correct and the way that he will execute his solution. So we say 4 multiplied by 1 is equal to 4. Then we say 4 multiplied by 0 is equal to 0. Okay. So quick. Okay. We're at our answer already. We need not go any further. Only one number ends with 04. And this is the one that ends with 04. Good. So because only one number ends with 04, we are sure that that one represents our answer. The correct answer is option A. That's very good, Jerry. Now we are going to finish Richard James Mathematics Resources in less than 20 minutes. I am sure that the examiner did not intend that we go through the entire process of multiplication, but that we use our common sense and arrive at the correct answer in the shortest possible time. What is $2.51 rounded to the nearest dollar? We are required to round the figure to the nearest dollar. So first we are going to locate the digit in the specified location. That is the digit that is to the dollar. Right? So that is the digit that we are talking about. In rounding to the nearest dollar, or in rounding in general, we generally check the digit that is next in order of significance. And that is usually the one immediately to the right. That is the one that is pointed to by the red arrow. The digit is a 5. Whenever the digit is 5 or more, we will add 1 to the digit that is in question. So the digit that is in question is the digit that is representing the nearest dollar. The one next in significance, if it is 5 or more, we are going to add 1 to this one. So what do? We add 1 to this. Why? Because this digit, which is the next in order of significance, is greater than or equal to 5. We therefore add 1 to 2. Complete the answer by including the decimal point and placed holding zeros. So a decimal point and place holding zeros are included. The correct answer is option D. Ordinarily, the 2 places of decimal would not have been necessary, but because the figure is representing money, the general representation of cents is included, because money is always in dollars and cents. What percentage of 80 is 16? The problem could have been conveniently written in another way. What is 16 as a percentage of 80? It would have been more obvious that the answer may be found by placing 16 over 80 and multiplying the result by 100. So, by rewriting the question, it becomes more obvious what we need to do in order to solve the problem. So, we have 16 over 80, and that we will multiply by 100. Why, Jerry? Why do we multiply by 100? Okay, we multiply by 100 because a percentage is a figure out of 100. So we are saying 16 over 80 is equal to what number over 100? So 100 may be written as a fraction that is equal to 100 over 1. So we may rewrite that. We may reduce the fractions by a common factor of 10. Of course, reducing by a common factor of 10 may be easily done by striking 1 0 in the numerator and 1 0 in the denominator. Okay, so that is our reduced fraction. And of course, we have a possibility of further reduction. We may further reduce the fraction by a common factor of 8. What do we mean by a common factor of 8, Jerry? Very good. It means that there is a number that is divisible by 8 in the denominator and a number that is divisible by 8 in the numerator. And of course, 8 into 8 is 1 and 8 into 16 is 2. And that is our reduced fraction. The answer is therefore option A. So we have 2 multiplied by 10 is 20, and here we have 1 multiplied by 1 is 1. 20 divided by 1, the result is 20. And that is represented by option A. This is, by its appearance, a very rigorous problem. But in fact, we may show that this problem is not so difficult after all. So Jerry, be not afraid. Be of good courage. This problem is not as difficult as it seems. Now, we are going to be using some basic principles in the manipulation of fractions in order to find our answer. So we are saying, when adding numbers that have the same denominator, we add the numerator and put the result over the common denominator, because we have common denominators already. So we just need to add the numerators. In this case, the common denominator is 12. Now the answer, being 1, tells us that the resulting numerator is 12. Okay, therefore, we are adding these. Say 5 over 12, 2 12ths, and x over 12. The answer is 1. But when we are adding numbers that have the same denominator, the answer is found by adding the numerators and placing the value over that same denominator. Therefore, the one that we have right here is a fraction whose denominator is 12. Because the denominator is 12 and the answer is 1, then the numerator is also equal to 12. Therefore, when we add all of these, we are required to get 12 over 12, because, as a matter of fact, 1 is equal to 12 divided by 12. Okay. Now, we are going to focus on the numerators, because we are sure that all the numbers in the numerator must be added to give 12. Adding the known numbers in the numerator, we get what? 5 plus 2 is equal to 7, and that we have right there. This means that when x is added to 7, the result is 12. We may ask the question, what number may be added to 7 so that the result is 12? Right? So we have 5 plus 2 is equal to 7. Therefore, if this is 7 and the entire numerator is 12, what number is added to 7 in order that the result is 12? So, what number may be added to 7 so that the result is 12? The answer is 5, and this is represented by option C. So let us take another look at the problem, Jerry. When adding numbers that have the same denominator, we add the numerator and put the result over the common denominator. That's it. So we are actually taking it step by step this time. Adding the known numbers in the numerator, which is 5 plus 2, we get 7. So the actual problem is 7 plus x over 12 is equal to 1. So, of course, the denominator is 12 and the answer is 1. This means that x plus 7, the result is equal to 12, which is a simple linear equation that we may solve. So then, we are sure that because the result is 1, that the numerator must be equal to 12, because 12 divided by 12 is equal to 1. So then, 7 plus x is equal to 12, and that is a simple equation that we may solve. We always solve these equations, Jerry. 7 is added on the left-hand side. We therefore need to subtract 7 from the right-hand side. Remember that when we are solving equations, we do the opposite of the arithmetic operation on the other side. Therefore, if we are adding 7 here, on the other side, we will subtract 7. Why? Because the opposite of addition is subtraction. So we have x is equal to 5, and we have taken another approach and we have arrived at the same answer, 5, and that is represented by, again, option C. Jerry, you take over and answer this question. You tell me what to do. This question says, what is the value of 5 in 4,509? So what do we do? First, we are going to identify the place values. So let us write down the number accompanied by the place values. So that's what we do, Jerry. And give me the next step. Okay, right. So the 5 is in the hundreds position. Therefore, it represents 500. That's very nice, Jerry. 5 is in the hundreds position. Its value is therefore 500. The correct answer is option B. Next time, I'll give you a more difficult problem to solve and see what you make of it. Let's go, Jerry. What is 15 multiplied by 1 and 1/5? To multiply the whole number by the mixed number, we first convert the mixed number to an improper fraction. So we have a mixed number right here to be multiplied by a whole number. So we are going to convert this to an improper fraction. And of course, we are identifying the whole number in the mixed number. We have the whole number, we have the numerator, and we have the denominator. So how do we convert that mixed number to an improper fraction? We are going to multiply the denominator by the whole number, then add the result to the numerator. So we multiply the denominator by the whole number. So we start down here. 5 multiplied by 1, and that is equal to 5. Then we move on. That 5 that we have right there plus 1 is equal to 6. So the 6 that we have is the result that is going to be placed in the numerator. That's the 6. And in completing the fraction, the denominator is the same denominator that we had before. No problem with that one. Good. No, Jerry. No, Jerry. We are not going to be inverting the fraction this time. It says here, multiplied by. When do we invert the fraction, Jerry? We invert the fraction when we are dividing. But this time we are multiplying, so we will not invert the fraction. So we have 6 over 5, which is what we have right here, multiplied by 15. And of course, we are going to write the 15 as a fraction. We may reduce the fraction by a common denominator of 5. And Jerry says that we mean that there's a number in the denominator that can be divided by 5, and there is a number in the numerator that is divisible by 5 also. So then we are going to do that. And of course, 5 into 5 is 1, and 5 into 15 is 3, and we are going to write down the reduced fraction. We know that 6 multiplied by 3 is 18, and 1 multiplied by 1 is 1. So what we have is 18 to be divided by 1, and the answer is 18. And the correct answer is represented by option B. The diagram below represents a pizza. Now, Jerry, you must be enthusiastic about solving this problem because you will get the opportunity to eat the pizza after we have finished solving the problem. First, we need to know the number of sections in which the pizza is divided. And of course, we are going to count them. The pizza is divided into 8 parts. Therefore, the fraction that represents the answer will have what? 8 as the denominator. Okay? So, the problem is saying that we should determine the fraction of the pizza that is shaded. Of course, we are not looking at the part that is shaded as yet. We have determined that it is divided into 8 parts. So 8 will be the denominator of the fraction that we are looking for. There we go. That's a very nice way to put it, Jerry. Instead of saying, let us shade the number of parts indicated in the question booklet, Jerry is saying we should say, let us eat the number of parts indicated in the question booklet. I think that if you eat the pizza, Jerry, our problems would have been solved a long time ago. And we would not necessarily get the correct answer. Therefore, what do? We just solve the problem as it is indicated in the statement that we have up here. So let us do exactly what the problem says. We are going to determine the fraction that is shaded, not the fraction that was eaten. Alright? So, we are going to shade the sections that are indicated in the question booklet. And we'll use a strategy in shading those sections. We'll begin at the one that we have right here, numbered 1. So we are going to begin at this one and shade the number of sections that we have indicated in the booklet. So let us do that. Okay, quickly we realize that we would have shaded 5 sections. So the number of parts that are shaded is equal to 5. The numerator is 5. Now I understand why you want to eat the pizza rather than shade it. You can get all of 5 pieces and you will leave only 3 pieces for me, right? That's not fair. The fraction represents 5 parts out of 8. It may be appropriately called 5/8. The correct answer is option B. The diagram below represents a pizza cut into several parts. What fraction represents the unshaded parts? 5 parts out of 8 are shaded. The number of unshaded parts is equal to, because we have 5 that are shaded already, and we have a total of 8, therefore, the number of parts that are not shaded, and Jerry will say, the number of parts that are, right, number of parts that were not eaten. And that is represented by 8 minus 5. 8, the total number, 5, the number of parts that were shaded. The correct answer is 3. 8 minus 5 is equal to 3. Therefore, the fraction is 3/8. The answers are given as decimal fractions. Therefore, we will do the necessary calculation dividing 3 by 8. So we have 3/8 as our answer. But the options that we have over here are all given in decimal fractions. So let us do our long division on the Next slide. So we are going to use long division this time. The fraction 3/8 means 3 out of 8. Numerically, it also means 3 divided by 8. So what do? We are going to say 8 into 3. 8 cannot be divided into 3, so we place a 0 over the 3, followed by a point, and say 8 into 30. So 8 into 30 goes 3 times. But we know that although it is able to go into 30 3 times, it does not divide into 30 exactly 3 times. So what do we say? 3 times 8 is equal to 24, and we are going to subtract the 24 from 30. So we have 30 minus 24 is equal to 6. Then 8 into 6, of course, you know that is not possible. What do? We cannot divide 8 into 6, so we place a 0 beside the 6, to the right of the 6. There we have it. We then say 8 into 60 goes 7 times. And of course, again, 8 does not divide into 60 exactly 7 times. So we say 7 8s 56. We subtract 56 from 60. And what do we get? 60 minus 56 is equal to 4. 8 cannot be divided into 4, so we place a 0 beside the 4 and say 8 into 40, and that's 5 times. So 5 multiplied by 8, what do we get? We get 40. And so 40 to be subtracted from 40, the result will be 0. And we are at the end of our long division. And that's our correct answer. The answer is option A. That's very nice. Jerry, it is very important for students to know certain decimal fractions, or to know the decimal equivalent of certain vulgar fractions. Some of the vulgar fractions include a half, 0.5, 3/4, 0.75, a quarter, 0.25, 1/8, 0.125, and so on. So it is very important for us to know the decimal equivalent of certain vulgar fractions. If we did, we would not have the necessity of working out this problem. As soon as we have discovered that the fraction is represented by 3/8, we could have written down the answer. Now we have something that Jerry does not like. We have two mixed numbers. Well, Jerry actually likes mixed numbers. What he does not like, he does not like to multiply by a mixed number, because when we multiply by a mixed number, we do not get the opportunity to invert the fraction. Okay? So Jerry is going to be disappointed at the solution of this problem. So we have two mixed numbers. Let us convert them both to improper fraction. And of course, we are identifying the parts of the mixed number as usual. So multiply the denominator by the whole number. Usually we start right here. Start from the denominator, multiply by the whole number. 3 3 is 9. And then we go up here. The 9 plus 1 is equal to 10. So the numerator is 10 and the denominator is 3. We'll do that with the other mixed number, identifying what each digit signifies. And of course, we're going to start down here again. 5 multiplied by 2 is 10. And 2 plus 10 is equal to 12. So the numerator is 12 and the denominator is 5. And Jerry is putting his hands over his eyes because he is so disappointed that we are not going to be inverting fractions in this particular case that he does not want to see or to have anything to do with the problem. The fraction may be reduced as follows. Of course, we are going to identify. Jerry, you cannot identify the common factors with your hands over your eyes. So we need to take a look at this problem also. You cannot risk getting any problem wrong because you do not like it. You have to solve every single problem and get 100% on your GSAT exam. So the fraction may be reduced as follows, and we have what? We know that there's a common factor of 3 in 3 and in 12. So those will take care of each other. And there's a common factor of 5 in 5 and in 10. Okay. And we have that. Now the reason why we did not reduce the fraction in 2 steps is because by seeing the way that we strike them, notice that the diagonal is a leading diagonal right here. We strike the 3 in a leading diagonal direction. We strike the 12 in a leading diagonal direction, showing that we are actually reducing 3 and 12 by the same factor. And of course, we have a diagonal, what we call a subordinate diagonal for the 10. In that direction and in that direction, showing that we are reducing the 10 and the 5 together. So we are saying 3 into 3 is 1 and 3 into 12 is 4. And of course, 5 into 5 is 1 and 5 into 10 is 2. Finally, we will say what? 2 multiplied by 4 is equal to 8. And 1 multiplied by 1 is equal to 1. So 8 divided by 1. And that is equal to 8. The correct answer is option A. Use the Venn diagram to answer the question. What are the members of set B? What is the other name that we use for our members of a set, Jerry? Very good. Elements. We may say, what are the elements of set B? So let us shade the set B in order that we may identify only the elements that are in B. Of course, Jerry, we know that you could identify them without we shading them. Richard James Mathematics Resources is designed in such a way that every solution is visual and will help even the weakest student. So we show set B in the entire diagram. You don't have to do it, Jerry. You can just write them down. But I'm just doing that even the weakest student will be able to use the resources and get a very good grade on the GSAT exam. So let us write down all of the elements that are in the shaded region, preferably in numerical order. So we are going to write them down in numerical order, beginning with the smallest number in this set. So we are going to put 2, then 4, 6. We do not put 12, right? Because we have a number that is smaller than 12. So we put 8 first. And of course, 10 is also smaller than 12. We put 10 next. And then finally, we put 12. Okay. The correct answer is option D. What are the elements of A intersection B? That is how it is read. When you see this thing that looks like an N, not actually an N, but in that general shape, it means intersection. And what is an intersection? The intersection of two sets is the set of elements that the two sets have in common. That means those elements that are in set A and those elements are also in set B. Therefore, in the Venn diagram, we are talking about those elements that are shared by A and B. So, the question is asking us to shade the intersection of the two sets, A and B. So, of course, let us shade the set A. Do not complain, Jerry. Let us shade the set B also. Good. The intersection of A and B is the set of elements that the sets have in common. This is represented by the set of elements that are in the dark region. So this is the dark region, and this is where we have the elements that are shared between A and B, and those elements are therefore in the intersection of A and B. So write down the elements that are in the dark region. So let us do that. Preferably in numerical order. Or we may say in computer terms, alphanumerical order. Which means whether they are letters or numbers, they are placed in a particular order that is a convention developed by computer scientists. So if Jerry wants to do information technology, he will learn about alphanumeric values. So let us continue. 6, 12, and that is the last one, so we are going to close our set. And 2, 4, 6, 12, that is represented by option C. What is the union of sets A and B? The question is asking us for the union of the sets A and B. This is the set of all of the elements that belong to A and B. All of them. So let us shade the sets A and B. Right. All of the elements that are in A and B. All of them together. And Jerry is so intelligent that he does not want me to do them one by one. So in this particular case, we'll just write them down. So let us now write down all of the elements that are in the entire shaded region. And we are going to do that in numerical order. And we are not going to take them one by one. We are going to just jump and write them down because Jerry is saying, I'm taking too much time doing all of that. Jerry, you are too advanced for GSAT. So there we have them, written down in numerical order. 1, 2, 3, 4, 6, 8, 10, 12. So let us see if we can do it from here. 1. What is the next number? 2. Then 3. Then 4. What is the next number? We do not have a 5, so we say 6. After 6, we do not have a 7, so we say 8. We do not have a 9, so we say 10. We do not have an 11, so we say 12. Right? And this set is represented by option D. Very nice. When we have a quotient that involves decimal fractions, we generally begin by expressing it as a vulgar fraction. Now, Jerry, this problem requires that we divide 0.75 by 0.025. So we are going to represent that as a vulgar fraction first. Now Jerry is trying to let me know that we have decimal numbers here, decimal fractions here, and decimal fraction here. So how comes it's a vulgar fraction? Well, Jerry, it is a vulgar decimal fraction. We express it in that form. That's an option. We now need to focus on the number of decimal places in the denominator. How many decimal places are there? 1, 2, 3. There are 3 of them in the denominator. We need to get rid of all decimal places in the denominator. So we multiply by the power of 10 that has 3 zeros. So that is our strategy. We have 3 decimal places in the denominator. Therefore, we are going to multiply the denominator by the power of 10 that has 3 decimal places. That power of 10 is what? 1000. So, multiplying the denominator alone by 1000 will change the fraction drastically. We need to cancel the effect by multiplying the numerator by 1000 also. So, our aim is to get rid of the decimal places in the denominator. Because we have 3 of them, we multiply by 1000. We cannot multiply the denominator by 1000 alone. We'll have to multiply the numerator by 1000 also. What happens? The numerator has only 2 places of decimal. A 0 will compensate for the deficiency in the number of decimal places. So then, because we have only 2 decimal places here, when we multiply by 1000, a 0 will have to be included. After the 75, we'll end up with 750. So let us do that. There we have it, 750 to be divided by 25. Reduce the fraction by a common factor of 25. So of course 25 will go into itself 1 time and 25 will go into 75 3 times. Of course, the 0 is not affected, so it is going to be 30. And what is that? The answer is 30. And the correct option is A. Now, number 19 is an equation. And the problem is saying if n plus 2 1/3 is equal to 3 1/6, which will give the value of n. So, because we know that it's an equation, we are quite familiar from practice papers 1 and 2. We are well familiar with solving equations. So we are going to solve that to say which will give the value of n. So let us treat the 2 mixed numbers as we would treat 2 simple terms in an equation. As a matter of fact, that is what they really are. They are just 2 simple terms in an equation, no matter what they look like. They may look a bit cumbersome, but they are 2 terms in an equation, and we'll treat them just like how we treat any other term. So what do we have? N plus 2 1/3 is equal to 3 1/6. We see that 2 1/3 is added to the left-hand side. So 2 1/3 is added to the left-hand side. What do we do? In solving the equation, we need to do the opposite of adding 2 1/3 on the other side, because in solving the equation, we need to make n the subject. So n will be on the left-hand side, and we need to ensure that we take the necessary steps to transpose this 2 1/3 to the right-hand side in order to get the correct answer. So we need to do that correctly. So we see that 2 1/3 is added to the left-hand side. So what do we do? There it is, added to the left-hand side. In true solution of equation style, we will transfer it to the right-hand side, subtracting it from 3 1/6. So because it is added on the left-hand side, we are going to subtract that 2 1/3 from the right-hand side. And what do we have? N is equal to 3 1/6 minus 2 1/3. Do not forget that in transposing or transferring a term to the opposite side, we need to perform the opposite operation. So if we are adding 2 1/3 on this side, we subtract 2 1/3 from the other side. The correct answer is represented by option B. If 3 t-shirts cost $510, which will give the cost of 8 similar t-shirts. Not 8 smaller t-shirts, 8 similar t-shirts. So let us use a simple argument to solve our problem. We are required to take the cost of 3 t-shirts and arrive at the cost of 8 t-shirts. Our proposed solution will take us from the cost of 3 t-shirts to the cost of 8 t-shirts via the cost of 1 t-shirt. So we are going to say that 3 t-shirts cost $510. We have the cost of 3 t-shirts. The cost of 1 t-shirt will be less. We therefore divide $510 by 3 in order to get the cost of 1 shirt. So 1 t-shirt is going to be valued at $510 divided by 3. And when we divide 510 by 3, we get 170. Now that we have the cost of 1 t-shirt, our next step is to determine the cost of 8 t-shirts. 8 t-shirts will definitely cost more than 1. We will therefore multiply the cost of 1 t-shirt by 8. There we have it. So, we divided by 3 to arrive at the cost of 1. Then, we multiply by 8 to arrive at the cost of 8. The correct answer is therefore option C. See, the cost of 1 t-shirt is $170. And then we need the cost of 8 similar t-shirts. So we multiply 170 by 8. And that is indicated by option C. Very nice.